In the last post on Foodimentals, I talked a bit about the magic of gluten. I just wanted to talk a little bit more about this and show how gluten works and show you an experiment to extract gluten from flour so you can better understand how gluten actually works.
Okay, in this bowl we have some normal plain flour in a Wet-Ex, and what I'm going to do is extract the gluten from the flour.
In flour you have two major proteins. These are called gliadin and glutenin, and those proteins, when they come together, they make a big blob that we really call gluten. Gliadin molecules are long molecules, but they actually form balls, and glutenin molecules sort of form a long, sprawling tangle. And it kind of looks like a big tangle of Christmas lights, like you would see when you open up the drawer at the beginning of the festive season. When you add water to flour, the protein molecules start to unfold. They start to lose their shape and turn into long, stringy molecules. Initially, they're kind of like a really thick liquid. But when you put some physical energy into this thick liquid, such as kneading, as you would do when you make bread, the protein chains come together in a big sort of shaggy mess.
We've got it to this stage. We've washed away a lot of the starch, and you can see what's left is this sort of kind of disgusting mass. But you can see that it's a bit stretchy. See that? That's basically the gluten. So what we're going to do now is just wash away the last bit of starch, and by squishing it with my hands, the gluten will start to develop and turn into a big ball of gluten. So let's wash it. It feels a bit like snot. Look at that. Now when we first picked it up out of here, we had this kind of stringy sort of mass. But here you can see that I've rinsed out the extra starch, and by putting that bit of physical energy into the dough, it's turned it into a ball, because it's all those proteins have formed cross-links, and it's given it structure, and that's why you can really see the elasticity of that has developed. When I push it down, it bounces back to its original shape. Here, I push it down, it's not really bouncing back to its original shape. It's quite plastic here, but the elasticity hasn't really developed. And the difference between here and here is just that extra physical energy of moving it around.
Now, when you make bread, you're using yeast to actually provide bubbles of carbon dioxide. So that's what actually rises the bread, but without the elastic and plastic gluten, that gas would just escape out of the dough and go away to the atmosphere, and the dough would never rise. So you need this sort of amazing complex and this amazing coming together of glutenin, gliadin, water and physical pressure to make this wonderful elastic and plastic mess that we call gluten, that we use to rise bread.
Are you ready for the test? Will it stick to the ceiling?